Hello, this is Rachel Babin from Oncology News Australia, proud producers of the Oncology podcast. In today's episode, Professor Eva Segelov interviews the inspirational David Fajgenbaum, who gave the opening address at ASCO 2020. David is known as the doctor who cured himself. He is a truly groundbreaking physician-scientist, disease hunter, speaker, and author of the best-selling memoir, Chasing My Cure, A Doctor's Race to Turn Hope into Action. There's a link to David's book in the notes. David's way of thinking and his changing of the research paradigm may help accelerate innovations across many specialties. This is an interview that will be of interest to anyone, not just those in oncology. For more information and to sign up to our weekly newsletter, visit oncologynews.com.au. This is Rachel Babin, and this is the Oncology Podcast.
So this is a really special podcast, and I'm really excited and humbled and awed because my guest is David Fajgenbaum. He's an MD, MBA, MSc, Assistant Professor of Medicine at the Perelman School of Medicine at University of Pennsylvania, and the Executive Director of the Castleman Disease Collaborative Network. He's the author of a book, Chasing My Cure, A Doctor's Race to Turn Hope into Action. And his story is so incredible that every time I see it, I can't help be overwhelmed with emotion. How it came to having the opportunity to interview David is that he gave the opening address at this year's ASCO meeting. And although we weren't able to be there in person, and obviously neither was he, the message that came through was so powerful. Now, being a virtual meeting this year, ASCO was harder to engage with, and I'm worried that people miss this absolutely inspiring and important session. So, new to Twitter, I naively tweeted a personal message asking David would he come on our podcast. I think he thought we were the Today Show, so he said yes. He was interviewed by the Today Show from Australia. I don't think that interviewers had much idea about anything they were talking about, but still. So very kindly, David said yes. I'm pretending that we have a multi-million audience, but I think there will be great interest in this from not only oncology, but from rare diseases. And from anyone who really wants to hear an inspiring story. So I hope that in this next while, we get a chance to not only hear David's story, but work through some of the incredible issues that it raises, the dilemmas, ethical dilemmas, opportunities, and most of all, the ability to shape your own destiny.
Well, Eva, thank you so much for having me on today.
Welcome, David. So as I've said, you've got an amazing story, and I'll ask you, if you don't mind, to tell us in your own words. I know you've said this before, but just want to hear this again. You were a perfectly fit third-year medical student one day, and then what happened?
Yeah, I was training to become an oncologist in memory of my mom, who had passed away just a few years before from brain cancer. And out of nowhere, I just became deathly ill. It really started with fatigue that I had never felt before. I noticed some lumps and bumps in my neck. I noticed fluid accumulating around my ankles, and it all just didn't really seem to make sense. And I was busy as a medical student. I was, trying to become a physician. And there's, as you know, there's no time in medical school to be tired or to take breaks. And so I just kind of kept pushing through. And I started getting really bad abdominal pain, and I really wanted to see a doctor, but I knew I just needed to make it through this one particular rotation that I was working on. And so I just kept working. And I took my exam, and then I went down the hall in the hospital to the emergency department. And to try to get checked out. And they ran a series of blood tests and came back and said, David, your liver, your kidneys, and your bone marrow are shutting down. We have to hospitalize you right away. And they did a full body CT scan at the time and came back with disseminated lymphadenopathy. And in the setting of flu-like symptoms plus many enlarged lymph nodes plus some really abnormal organ function, it made everyone really concerned that this was lymphoma. And unfortunately, this would be the beginning of a very long diagnostic odyssey. Over the next 11 weeks, I gained about 70 pounds of fluid. I had a retinal hemorrhage that made me blind in my left eye. I needed dialysis because my kidneys completely failed. I needed daily transfusions because my bone marrow wasn't functioning appropriately. And I was so sick that a priest came in and administered my last rites to me back in November of 2010. And I've really considered that moment to really be the start of my overtime, this sense that, and I'm sure the listeners will appreciate that well from a different kind of football than I'm used to, but extra time you didn't think that you'd have, but time where you really have to make the most of it. And thankfully, right around the time that I nearly died for the first time, the diagnosis was finally made. Idiopathic multicentric Castleman disease. And I was started on treatment and my life was saved, but unfortunately I would go on to have relapse after relapse after relapse.
Do you remember the priest coming in, or is it just something that family have told you?
I have some vague memories from that experience. Because my liver and kidneys were shut down, I was very confused. My BUN, for the physicians listening to this, blood urea nitrogen was over 200 milligrams per deciliter. So it was very, very, very high, like 10 times too high. So my kidneys just were not functioning. I was on dialysis and I was very confused. And so I didn't really know exactly what was happening, but I was scared. I guess I had enough sense to know that things weren't good, and I was really afraid.
So what treatment did you have at that stage, David?
I got a single dose of rituximab. It's interesting because at the time there was a clinical trial for idiopathic multicentric Castleman disease going on just down the road. My doctor at Duke did not actually know about the trial going on just down the road and really tried rituximab, which is typically not very effective for the subtype of Castleman disease that I have. But that was the only drug that he was aware of could be tried. Thankfully, that single dose of rituximab quieted things down enough. I continued to get weekly doses of rituximab for the next few weeks, but then I quickly relapsed, and rituximab was never effective in future relapses, but it worked, and that's I guess all that mattered. It got me through that, and unfortunately, I would need many more intensive therapies moving forward.
So when you recovered from that, did you start researching into Castleman's disease?
I did, but at that stage, the only research that I was doing when I recovered at that stage was who can I go see? Who is the world's expert for this disease? And I found out that the world's expert for idiopathic multicentric Castleman disease, which I should mention, IMCD is a hyperinflammatory disorder. So it actually shares features that are kind of autoimmune disease-like and also lymphoma-like. It really sits at the intersection of the two. But the heart of it is a cytokine storm, which of course cytokine storms have been in the news quite a bit lately because unfortunately COVID-19 will ignite a similar cytokine storm in the most sick patients to what we see in Castleman disease. And I found out that Dr. Fritz Van Rhee in Little Rock, Arkansas was the world's expert for IMCD. And I traveled out to see him. And when I went to see him, unfortunately, I relapsed again. This time rituximab was not effective, and I continued to get sicker and sicker and sicker. And I was even tried in that experimental drug, siltuximab. And I remember my dad and I just being so hopeful that this drug was going to turn things around. Siltuximab targets interleukin-6, which is a really important cytokine in the immune response. And we hoped this was it. We thought that this is, and actually it's very effective for a number of other patients. Unfortunately, it didn't work for me. And so I needed multi-agent chemotherapy. I got a combination of adriamycin, Cytoxan, etoposide, Velcade, dexlutamide. That combination of chemotherapies, which is often used in multiple myeloma, was very effective for me. So I went from really being on my deathbed now at this stage for the third time to starting to feel better with every dose of adriamycin. I mean, if that gives you a sense for just how sick I felt, I actually felt better with every dose of chemo.
And how many cycles of chemo did you have at that stage?
So I actually only had one 21-day cycle. So the 21-day cycle that they do for multiple myeloma, often you'll do multiple cycles of it, but I had improved so much by the end of it that we felt that we had really just stopped this cytokine storm. Unlike myeloma, where you need to try to get rid of all disease throughout the body, we call it idiopathic because we don't know what ignites the cytokine storm. But for the most part, we feel that if you can stop the cytokine storm, that you don't need continued rounds of chemotherapy.
And so at this stage, were you still in medical school? What were you doing?
Yeah, so at this stage, I'd spent almost 6 months hospitalized, and I was finally well enough to be discharged from the hospital. And I stayed on medical leave for another 6 months. I took a full year off of medical school on medical leave. I continued receiving that experimental drug, siltuximab, even though it hadn't worked acutely when I was in the hospital. We hoped maybe it could prevent a relapse. And then I was able to go back to medical school, and I was so hopeful that that drug, siltuximab, was going to keep my disease in remission and that I could go back to my grand plan of treating cancer patients one day in memory of my mom. And then I relapsed on that drug. So about a year later, I had a full-blown relapse back in the hospital with multi-organ failure, liver, kidneys, bone marrow, as sick as ever. And I nearly died for the fourth time. Shortly before I reached my worst point, my doctor came in to see me, Dr. Van Ree. And so I mentioned he's the world's expert. And I said, okay, Dr. Van Ree, we've tried siltuximab, which targets interleukin 6, and it didn't work. My interleukin 6 levels are not very elevated. What other targets are there that we could go after with drugs? And he said, well, no one knows. And I said, okay, what other promising drugs are there out there that maybe we could try that could maybe work for me? And he said, no one knows. And I started trying to get into, well, how does this happen in the first place? Like, why is my immune system attacking my organs? And again, no one knows. And I consider that conversation to be such a critical moment in my life, because for the first time in my life, I'd always been very hopeful, and this idea that there must be someone out there with the answer. You just have to find the expert. Someone knows it. And I even in my book Chasing My Cure, I'd call it the Santa Claus theory of civilization, and that's this idea that for every problem out there must be a team of elves in a magical workshop trying to solve your problem. And Google kind of reinforces that concept, because it seems like any question you can ever think of, you type it into Google and Google finishes your question. And you're like, oh, wow, someone must be thinking about this. Oh, and there's 1,000 answers to it. But the reality is that for many diseases, in fact, most rare diseases, you can find the expert, but the expert doesn't know because the world doesn't know. And so that's what I learned really in a very sobering and difficult way. And when my doctor left the room, and he started me on the same 7 chemotherapies as before, and thankfully it saved my life, really, again, just in time. But when he left the room, I turned to my dad, my sisters, and my girlfriend, and I told them, I said, I'm going to dedicate the rest of my life, however long that may be, to trying to find a treatment and maybe a cure one day for Castleman's. And they were obviously supportive, but I think that they were most interested in me just surviving that episode. There was no time for heroics, which I understand. But I also realized that when I said that to them, I think I realized the reality of how unlikely it was that as a medical student, and based on where the field was, that I was going to make any sort of progress for my disease. Maybe it was a 1 in a million chance, but I knew that if I didn't try to turn what I like to talk about is turning hope into action. I was hoping that there would be a treatment for years. And then I realized that if I'm going to hope for it, I should probably take some action to make that happen. And once I had a shift in mindset from being hopeful to turning hope into action, that's really when everything changed.
So it sounds like a good idea, but how do you actually make it happen?
So I think that in my case, the way that I try to make it happen for Castleman disease is that I created a foundation called the Castleman Disease Collaborative Network. And there actually were already 2 foundations that existed for Castleman's before we got started. So when I started the foundation, I said, okay, we're going to create this organization to accelerate research for Castleman disease, but we can't just do what's been done, because clearly these organizations have been doing great work for years and very little progress has been made. We have to take a different approach. So we started out by saying a typical rare disease organization will raise money and then invite researchers to apply for that funding to do research. And that's kind of the way. And then you pick the best applicant. And that works really well if you have thousands of applicants and you have millions and billions of dollars to give out. You get a lot of applicants, you get great ideas, you can pick the best one. But if you're a rare disease, like Castleman disease, you might have a handful of people apply for your funding. And it becomes extraordinarily unlikely that one of the 5 people applying is going to have both the best idea in the world for what research should be done and also be the most qualified person in the world to do that research. It also means that all of the other ideas that anyone else could have, those ideas never come to fruition, because unless you apply for a grant, that idea that you might have doesn't happen. And so we said, let's change that. Let's make it so that we crowdsource. So we turn to patients, physicians, and researchers for ideas on what research should be done. And then once we had that list, then we say, well, who's the best person in the world to do these things? And then we went to them and we recruited them to do Castleman's research. And most of the time when I went to them, their first question was, I would go through my whole pitch on why they should do it. And then their first question is, what's Castleman disease? And I'm like, oh gosh, that's not a good sign. And that's okay, because what we were doing is we were trying to bring in the best people in the world, whether or not they knew what Castleman's was. And the reality is they never would have applied for grant funding if we hadn't gone to them proactively. And so that was a major aspect of our success, is just really changing the way that we drove forward research, and in a way that involves patients too, importantly. And then the second part of my turning hope into action was to begin conducting laboratory research at Penn. There were no labs at Penn, where I was in medical school, dedicated to Castleman disease, but a principal investigator gave me some space in her lab and told me I could, use her space. Again, I knew that it was unlikely I was going to make any progress in time to save my life, or to make any sort of a meaningful difference, but I knew that there was no chance if I didn't try.
So just coming back to going to recruit the best people, who did you find? What sort of fields were they in? And why did they come, apart from the fact you're very charming, why did they come over from what they were already doing?
So the number one, when we did the crowdsourcing effort, we got over 60 different ideas for research studies. So again, rather than getting 5 ideas from 5 researchers, and again, only the right researcher applying for the right project at the right time, we got over 60 ideas and we prioritized them. And our number one research idea was to look for a potential virus that could be causing idiopathic multicentric Castleman disease. We know that a virus, HHV, can cause a similar syndrome that looks a lot like IMCD. As I mentioned earlier, COVID causes an almost identical cytokine storm to what we see in IMCD. So it was a really important hypothesis. And so we went out and tried to recruit the world's best viral hunter, someone who they spend their whole careers looking for new viruses, looking for existing viruses, but really hunting for viruses. And we immediately went to kind of the 2 most prominent viral hunters. And what was interesting is when we went to them, we said, okay, we're going to give you money. We're going to give you samples. All you have to do is the research. And that really changes things, because I'm a researcher myself. And I have to say that we love to do research. What we don't love to do is the logistics of trying to get our tissue samples, the logistics of writing grants to get the funding. But if we can go to them and eliminate those 2 barriers and just say, you just need to do what you love to do and what you're good at doing. We'll handle the rest, and we'll help you to interpret the results. We'll provide that Castleman disease perspective in understanding what the results are. You just need to do what you do and what you're good at. And it was really well received. And then we went to study number 2, which is, okay, we know interleukin 6 is important. So we suspect that some circulating factors are important in Castleman disease. So maybe people where interleukin 6 blockade doesn't work, maybe we'll find another circulating factor. Maybe it's IL-7, who knows, that's in the blood. But the most important thing to do for that is to then do serum proteomics to measure all of the proteins we can in the blood of Castleman's patients. And we went out to recruit the best serum proteomics researcher. We ended up actually finding a company named SomaLogic, and we decided to work with them directly. And so this is kind of the process we went down, where it's, okay, what is the work that needs to be done? And then once we decide what we're going to do, then you go out and you find who is the best person in the world to do it. And you make it as easy as you can for them.
It's quite a novel paradigm on one side, but on the other side, it seems bleedingly obvious. And it's obviously been highly successful, and we'll talk about that. But has this paradigm been taken up by anyone else, or are you sort of looked on as a very unusual sort of framework?
So I think the answer is yes to both, but thankfully the order is reversed. So early on, we were thought of as very unusual, and there certainly was pushback within the Castleman's field. We actually had a few scientific advisory board members resign from our scientific advisory board because they didn't like the way that we were doing research. They said, well, I could do the work. I could do that study that was prioritizing. Said, you could, but you're not the best person in the world to do it. And our principle is that we find out the most important research and then we find the best person in the world to do it. And so there was a lot of pushback. There's in research, there's sometimes oligarchies where a few people kind of have control over science and samples and research, and we wanted to democratize research, and so there certainly was pushback, and people looked at us like we were a little crazy, and we were a little crazy, but like you said, it was a very simple concept. So a lot of people really did buy into it, especially our patient community. They love that their voices could be part of deciding what research should be done. And so we were able to, so despite the people, giving us funny looks early on, we were able to generate some progress and really make an impact. At the end of the day, it's not about how you do it, it's about what you achieve. And of course, what you achieve is a direct result of how you do it. But because we achieved a lot, and because we have continued to achieve a lot, our approach, what we call the collaborative network approach, has become a model for other rare diseases. And a number of groups here in the States have taken on this collaborative network approach. And there's an organization called the Chan Zuckerberg Initiative, which you may be familiar with. It's Priscilla Chan and Mark Zuckerberg's, their foundation, that has actually created a campaign called the Rare as One Initiative, where they're funding groups to follow a similar blueprint to the one that we've established. And we work really closely with CZI to do this. And it's another reason why I wrote Chasing My Cure, is to share and to kind of evangelize about the approach that we've taken, because it is so simple, and because I want to just share these messages and these blueprints with others.
So you mentioned that you had patient samples and you would take them right to the researchers. Can you tell us about, I know you've got an extensive tissue bank now and sample bank. That would have started with a very first sample. It was probably yours, I would guess.
You're right. Yeah, you're right on all accounts. So it started with my samples, and we really for that first study, I mentioned the viral hunting study. It took 2 years of basically scavenging the world to try to get our hands on any frozen samples from Castleman's patients that we could. And we spent those 2 years, and we finally got enough samples. This physician scientist needed, I think he needed somewhere around 30 samples total. I think we ended up delivering 34. So we were able to achieve the number that we needed. It took 2 years. And that process made it pretty clear to us that this isn't really a sustainable model when you're just going to doctors and scientists to get samples. Because what we learned is that most physicians and scientists aren't thrilled to share samples. And that if they have the samples, they want to use the samples, even if they want to use them. Sometimes years and even decades can go by without using them because they're busy with other things going on. And so that's, in my opinion, that's unacceptable, but it's their choice unless you go to the patient. And so what we changed is that instead of going to the physicians and the scientists to say, will you share your samples in your bank, we created a protocol where patients can consent to us getting all of their tissue samples, and then we can then request the samples from the hospital or from the lab, and it's the patient is now the one initiating it. We call it patient-powered research. When that happens, we almost always are able to get the sample, and so we've shifted gears a little bit from just trying to work with physicians and scientists. We still certainly do, and any physician scientist listening to this who wants to share samples for Castleman's research, I would love to collaborate with you. But at the same time, we've really shifted gears quite a bit to where we work directly with patients, and patients like me, we want our samples to be used for research. We want solutions. We want treatments. We don't want our samples to sit in freezers for 10 and 20 years.
I think that's a rather undiscussed issue around tissue bank. Same in the cancer field. So much energy goes into collecting them and maintaining them, but actually using the samples, sometimes we haven't done it justice. And I think it's because we don't have that approach, as you've explained, where you know the project already.
Exactly. Yeah, if you're just kind of banking to bank samples, then of course samples will likely sit around for a while. But if you're obtaining and banking the samples in order to do X, Y, or Z projects, then they get utilized more quickly. I haven't yet figured out the right name for it, but I'd love for us to come up with a new name for biobanks. Rather than being a bank where you think about holding things, I wish it could be more of a marketplace where they come in and then they go out. And because a sample that's in a bank is not useful to anyone. A sample, or it can be useful in the future, but it's all potential. Whereas if it's more of a marketplace where it comes in and then work gets done on it, that's, I think, what we should all work towards.
All right, we'll try and think of a new name.
Yes, we need a new name for that. I don't know. Marketplace seems a little strange too, so I think we can work on that.
So what's happening with you personally at this time? You're setting up this organization. Have you finished medical school? What are you doing? You're in a corner of someone's lab. They probably gave to you out of sympathy, thinking
Yeah.
you're quite crazy. What was happening there?
Yeah, so I was a fourth year medical student. I set up the foundation, the CDCN, and yeah, I was conducting laboratory research. I had an incredible mentor, Dr. Arthur Rubenstein, who was providing guidance and support during this time, which was really critical because, as you know, I was running into a field of landmines, and having someone like Arthur, who's this really incredibly well respected and internationally renowned endocrinologist, who kind of knew where the landmines might be, could give me advice along the way. Be careful about this, think about that, run here, stop there. That sort of advice was really critical for me. And we were making some progress. We were getting people on board with the CDCN, and then all of a sudden I had another deadly relapse. So I was back in the hospital. And this one was maybe one of the hardest for me emotionally, because I just gotten engaged to my fiance Caitlin, and I was so hopeful that I was actually getting weekly chemotherapy at the time, and we hoped that the chemo could keep me in remission and prevent a relapse. And I just wanted to make it to our wedding day more than anything. So it was really, really difficult, that fifth episode, to really relapse on these drugs that we thought could keep me in remission, relapse despite all of the hard work, despite creating the CDCN, despite the research that I was doing. None of that was able to stop it. Thankfully, I got the same chemotherapies again, and again they saved my life. Really, this time, I guess each time it had been just barely, but this was a really scary time. There was even a point when I was at my worst where the doctor came in and evaluated me, and then about 2 minutes later, the nurse came in and started asking my family questions about, do I have a will in place, or is my paperwork in order? Am I kind of prepared? And the doctor didn't say it to me, but the doctor clearly said it to the nurse that I wasn't going to make it. And so it was frightening again. But thankfully, I survived. When I got out of the hospital, so this is now the fifth time that this has happened. I knew that I didn't have time didn't have time. Period. I think that's kind of a theme of my life, is time and how powerful and important it is. But I knew I didn't have very much of it. So I went back to all of the samples. I've been banking samples on myself leading up to that relapse, which maybe wouldn't surprise you. So been banking samples, and had actually encouraged one of my doctors to do a lymph node biopsy. Yes, there's some clinical rationale for it in case I had actually developed a lymphoma, but also there's research benefits from it. And so as soon as I had enough strength and I got out of the hospital, I went back to the lab and started going through all the data that had been generated, and also started performing additional experiments. I ended up identifying a particular communication line called the mTOR pathway that my proteomic data and some IHC data I had generated suggested that this pathway might be turned on. And I did a final experiment, which I shared during the ASCO talk, and you would have seen really almost in black and white that there was just there was an incredibly strong signal for mTOR activation. The reason this was really important is that as I was doing my research, I wasn't doing research for research's sake to say, like, I want to find out what's going on. It was, I'm doing research to try to find something that I could direct a drug against. If I can find something in my samples that is up where there's a drug that takes it down, or something in my samples that is down where a drug can lift it up, that's what I'm looking for. And I found that with the mTOR pathway. There's obviously no guarantee that if you find that a pathway is activated, there's no guarantee that blocking it is going to save your life or prevent a relapse. There are many things that are too high that you can block it and it doesn't matter, but it was a lead and we didn't have any other leads. And sirolimus is an FDA-approved drug. It's an mTOR inhibitor. It works really well at inhibiting the mTOR pathway. It's also a very good immunosuppressant that you give to people that get kidney transplants. And so I shared the data with a couple of my doctors, and we all agreed that in the absence of other options, that I should start trying sirolimus. So I started taking it right after that relapse, and I generated this data. And it's been over 6 years that I've been in remission on this drug. And in my first 3.5 years, I nearly died 5 times. And now it's been almost, and I can't believe I'm going to use the word almost, because I really don't like to round up. And I know that I can't round up, but July 5th, if I'm fortunate enough to make it to July 5th, that will mark 6.5 years that I will have been in remission while I've been on this drug. And obviously it's been just amazing to have this time. I was able to get married to Caitlin, and my hair actually grew back just in time on my wedding day. So from the chemo, it looked like I had like a buzz cut on my wedding day, which was actually pretty important to me. I wanted to have some hair look like, I didn't want the external reminder that I had just gone through, all that I had gone through, and also the external reminder of what was kind of brewing beneath the surface. But I made it to my wedding day, and Caitlin and I, we had a daughter 2 years ago, Amelia, and so it's been like a dream.
It's such an incredible story, and I think is a tribute to you and to Caitlin, because I'm sure the people around you had a major impact on your work, your psyche, just your everyday being.
You're absolutely right. Just looking back, and actually the process of writing Chasing My Cure, I should have appreciated Caitlin and my family as much as I do now, but it actually was the process of writing it out. I'm typing this and I'm like, oh my gosh, like because a lot of these memories I intentionally buried away. I mean, you don't want to think about having your last rites read to you, and you don't want to think about these sort of things all the time. At least I haven't. But actually I had to pull those out. And in the process of doing it, it just made me appreciate Caitlin and my family and her family and my friends so much. And it also made me realize that it wasn't just emotional support, but I mean, there were times when it was so painful to breathe because of all the fluid in my lungs that I just wanted to stop. And that with their encouragement, I could keep pushing through the pain. And because I knew that I needed to do it for them too. And that it wasn't just me fighting for me. I knew that I needed to fight for them as well. And my book's titled Chasing My Cure, but I think it should be retitled Chasing Our Cure, because it was not just me chasing my cure. It really has been an army of people. I talked about the Castleman Disease Collaborative Network a bit, my family. Of course, once I got on sirolimus, and since I've been in remission, the last 6.5 years, I've been able to really run full speed after Castleman disease, continuing to expand the collaborative network approach, continuing to look for drugs that could work for other patients. We've started a clinical trial, so the drug I'm on, we've given to other patients. In fact, actually, now that I think about it, the second patient ever treated with sirolimus is actually an Australian patient, and her doctors had gone to a meeting that I presented some data about sirolimus helping me, got in touch with me. And this patient, who's doing really well in Australia, was the second patient treated with sirolimus. We actually described her in a paper we published about a year ago in Journal of Clinical Investigation. But we've given sirolimus to other patients. Unfortunately, it has only worked in about a third of patients. And unfortunately, siltuximab, that IL-6 blocker, which is now FDA approved, only works in about 1/3 to 1/2 of patients. And so when I say only, I think that that's not probably the right way to start it. Like, thankfully, it works in 1/3 to 1/2 of patients, because it is life-changing and life-saving when siltuximab works. I just want these drugs to work for everyone. And so, my mission and what we do is say, okay, Cetuximab works for 1/3 to 1/2. Sirolimus can work for about 1/3 of the people who don't benefit from cetuximab. So we're a little bit over half of the population. What else can we identify and discover for the remaining patients where there aren't drugs? And that's what keeps me up at night and what keeps me working really hard every day.
So obviously looking for the etiology is important.
Yes.
Are there still theories that it is a virally driven disease? And that might bring us into talking about the C word as well.
Sure. We've done now 3 separate studies looking for an active viral infection in Castleman disease patients, and all of them have come back negative. So we have not discovered a new virus. We haven't discovered a clear association with an existing virus. As I said, that was our number one hypothesis going into this. As you know, and as we've all become virologists since COVID-19 has emerged. If you're not looking in the right place, you don't find the virus. If you're not looking at the right time, you don't find the virus. And so we know from the studies we've done that we are not able to identify an active viral that's replicating, we can't find RNA or DNA from a virus in blood or lymph node tissue from IMCD patients in the samples we looked at. But that doesn't mean that there wasn't a viral infection 2 months before, and that Castleman disease could somehow be ignited because of a previous infection that's now cleared, and that it's actually the virus isn't there any longer, so you can't find it, but that it could have initiated it. We don't know if maybe we're looking in the wrong compartment. Maybe it's in the bone marrow. Maybe we can find evidence of the virus in another compartment of the body. And so I think that it's really hard in science and in medicine to rule things out, but we can say that as of right now, we have not yet found an infection. We've looked really hard with some really, really good viral hunters, the best that there are. Really, we've actually ended up working with 3 separate groups on separate sets of samples, really the most rigorous way you can do it. And we haven't found one, but we also recognize that there could be reasons that we haven't found. So we're going to we continue to look for pathogens that could be initiating IMCD cytokine storms. I think that COVID has probably pushed us even more in that direction, because it is incredible. If you look at a cellular level and look in the serum proteome of a patient with COVID-19, it is almost indistinguishable from the cytokine storm that we see in IMCD. The cellular changes, the inflammatory changes are just identical in the most sick COVID patients. Of course, most patients have a mild infection with COVID, but for the small percentage that have the cytokine storm, it is almost indistinguishable from an IMCD cytokine storm. And as a result, a number of Castleman disease drugs are being tried against COVID-19. There's one anecdote I'll share is a drug called tocilizumab or Actemra, which of course is used in CRS related to CART therapy. And I think I shared this during the ASCO talk, but actually that drug was developed by a close friend and colleague of mine, Kazu Yoshizaki. He developed the drug about 30 years ago. And he first showed that this drug worked in mice. And then when he was getting ready to give it to humans, I had heard that Kazu gave the drug to himself as the first human to get it. And I said, Kazu, Makoto just told me that you gave tocilizumab to yourself to prove that it was safe. And he said, no, I didn't give it to myself. The nurse, she gave it to me. Exactly, Kazu. So Kazu he developed the drug. He was the first human to receive the drug. It went on to get approved in Japan for Castleman disease. And then years later, it got approved in the United States. And then I assume also in Australia for rheumatoid arthritis. And now it's one of the most promising drugs in the fight against COVID-19. And I think this is an important example to highlight for scientists, but also for rare disease advocates, that drugs developed for rare diseases where there is likely to be a very small population that can benefit, those drugs can often have incredibly broad impact, as we're seeing with tocilizumab and rheumatoid arthritis and cancer in COVID. And I hope that helps to encourage further drug development in rare disease.
So that brings us nicely to this issue of repurposing drugs. And certainly in cancer, there are some very common therapies where there's actually quite compelling evidence, beta blockers, statins. I'm a bit of an aspirin fan as well. It's hard, though, to get interest in repurposing drugs.
It is. So there are somewhere around, and the numbers aren't easy to get your hands on, somewhere around 1,500 to 2,000 drugs that are FDA, EMA approved compounds. And they're somewhere around, and it really depends on how you split up diseases, somewhere around 10,000 human diseases. Of course, it could be as many as 100,000 if you subtype things further. But if you think about it, about 2,000 drugs, 10,000 diseases, those drugs are only approved for about 1/4 of all human diseases. So 3/4 of human diseases don't have an approved compound or approved drug. And as you said, many of the drugs that already exist that are approved for one thing may have activity and have been shown in many cases to have activity against other diseases. I mean, sirolimus is just this perfect example. It was developed for kidney transplantation 30 years ago. It's used in a rare lung disease, and it's saving my life from Castleman. I'm talking to you today from Philadelphia with my 2-year-old daughter in the room next to me because of this drug that no one had ever thought to try for Castleman disease. And so the real question that I have, and something that I'm also evangelizing about, is just the question of how many other drugs are there out there that are just hiding in plain sight. This drug was at my neighborhood pharmacy. I walked past it for years when I was in and out of the hospital, and no one thought to try it. And so the big problem, the reason that no one thinks to try it is because, as you said, there's very little interest and incentives in place to repurpose drugs, especially a drug like sirolimus that's generic and that no one's really making any money off of it. And it's not that there's this kind of evil conspiracy to not study drugs where there isn't money. It's just really hard to do a trial if there's no one who's willing to fund your trial. And so in our case with sirolimus, we went and we got federal government funding from the US NIH, and that was what enabled us to do this clinical trial of sirolimus. But unfortunately, that's not a very sustainable model, right? The federal governments for every country can't fund every trial of every possible drug that could be used in every disease. And so that's why it is important to figure out incentives that can work for pharmaceutical companies so that they're in a place to want to spend money on drug repurposing. And so I'm just hopeful that we can figure out some solutions to encourage more and more drug repurposing.
And specific grants for that, and also the issue of engaging low and middle income countries in these drugs where if there is a breakthrough, they will be able to afford it for their populations.
Yeah, that's one of the advantages of drug repurposing, is that if the drug is already approved for a more common condition, then if it is shown to work for a rare condition, it'll maintain the common condition price. So it's sirolimus is cheap because it's generic. If it was initially developed for Castleman disease, as you know, when you develop a drug for a rare disease, usually the price is a lot higher than if it's for a common disease, but it'll maintain its cheap price tag. So that's one real advantage of drug repurposing, is that if you can show that one of these cheap drugs work, now it's going to be much more accessible in your country.
So I want to just bring you back to your own story and your initial desire to be an oncologist. Are you disappointed that you didn't get there? You got diverted?
I wouldn't say I'm disappointed. I think that when I set out to become an oncologist, I made a promise. First, I made a promise to my mom just before she passed away that I would dedicate my life towards helping other college students that were dealing with illness or death. And I started an organization in her memory called AMF. The promise I didn't make to her, but that I made to myself just a few weeks after she passed away, was that I would dedicate my life to chasing after diseases like cancer that took her life. And I saw being an oncologist and treating cancer patients as a way to help people like her. But I also, from the very beginning, knew that research was going to be another way to help patients like her. And so I think that the goal when I set out to be an oncologist was just to help people struggling with awful diseases. Though I don't see patients clinically, I finished medical school, I finished business school, but I don't treat any patients clinically. I know that I'm able to have an effect on patients out there through the research that I do, and I love every minute of it. So no regrets.
Tell me, how important is having a business degree to what you do and to medical research?
It's had a really big impact. So as a fourth year medical student, I mentioned I relapsed, and I had that fifth relapse, and I ended up identifying a drug that could save me. But in the process of starting the Castleman Disease Collaborative Network, doing research, it became really clear really quickly that some of the greatest hurdles in the way of progress had nothing to do with science or medicine. They actually were issues of people not collaborating, no sort of strategy, inefficient use of funding, inefficient use of samples. These are organizational problems, managerial problems. So I felt that if I could do an MBA, I could pick up some of the skills to help with overcoming some of these hurdles. And frankly, it would also give me time to continue to do my Castleman's research. Whereas if I went on to an internal medicine residency, I would have had no time to continue any of my research or any of the work I was doing with the foundation.
And do you think there's still a lot to learn in that field as well about how we can collaborate better? You are so idealistic. How have you remained so in the face of some situations, even in research or medical practice,
Yeah.
that are not challenging to that?
I think that I'm far less naive and idealistic now than I was when I started. So you can imagine I was very idealistic and very naive early on, but I think I've gotten a little bit closer to unfortunately to reality now. I think that there have been a couple silver linings of the COVID-19 pandemic. Nothing will make it positive. It's been unequivocally negative in every way, but there are a few silver linings. Actually, this is something my mom taught me, and that's that during tough times we shouldn't just look for silver linings. We should look to create silver linings. So during a tough time, say, what can I do today to make this really bad thing positive? And I think there actually are a couple silver linings here with COVID. So the first is there has been incredible sharing of data with COVID-19. This sort of open access, everyone can access the data as soon as there's any insights, it's getting shared. That I really hope will continue after COVID, and I hope it'll spread throughout the medical field. Additionally, there's been incredible coordination. So within countries, within hospital systems, at Penn, there are multiple committees that review every clinical trial idea, basic science ideas. There's coordination in ways that I've never seen before. There's efforts to reduce redundancy in ways that I hadn't seen before, which I think, again, I hope that will spread over to other diseases. And the third is the emphasis and the interest in drug repurposing. And the reason everyone's interested in drug repurposing for COVID-19 is because everyone says, well, we don't have time to develop a new drug. We got to save people tomorrow. Well, every rare disease patient listening to this podcast is going to say, hey, we don't have time to wait for a new drug for my disease either. We all have urgency. Just because COVID is obviously terrible in a global pandemic, we should feel the same urgency for all diseases that we're feeling right now. And I'm really hopeful that this urgency and this interest in drug repurposing will continue in other fields. And one thing I'd mentioned around this idea of creating silver linings is that I tried to back in early March when COVID was really hitting the States for the first time, think through, well, what could our group do that could be useful? We have experience studying cytokine storms. We do a lot of drug repurposing. What could we do that could be helpful? And I remember finding myself hoping that some researcher somewhere would follow our blueprint and they would follow the same sort of drug repurposing approach that we've been taking. And then a couple minutes later, I said, well, wait a minute, if you're going to hope that someone else is going to do it, you should probably act. And so we created something called the Corona Project, which is the world's only database that I'm aware of that tracks all drugs that have been repurposed against COVID-19. Amazingly, so when we started out, we thought, well, maybe there have been 20 or 30 drugs that have been tried. We're up to over 150 different drugs have been tried to treat COVID-19. So you hear about a couple of them in the news. You hear about hydroxychloroquine, you hear about dexamethasone, you hear about remdesivir. Over 150 drugs have been tried. And so we maintain this database, and it's an incredible amount of work. We have an army of about 40 volunteers that are constantly combing through published literature on every paper that comes out with anything related to COVID-19 to pull out every drug that's been given to a human. And anyone can access that at cdscan.org/corona. And this is our attempt to create a silver lining, which is, this is an awful thing, but can we create a system to track drugs that are being used? And can this be a model for other diseases?
And from Australian perspective, we've had quite a different experience with COVID, thankfully.
Yes.
What is it, do you think, that makes such a difference between the severity of the illness and how does that sort of parallel with Castleman, or does it not?
Yeah, it's a really good question. I don't think we know why there's so much heterogeneity and severity of the illness. I think that we feel pretty confident it has nothing to do with the virus being different or mutating. It's really all about the host response. And so the tendency for a cytokine storm, we haven't yet figured out why some people have more of a tendency than others. But I mean, I would say for me, I've been on like extreme quarantine mode for the last few months because I know that my immune system has a tendency towards a cytokine storm. And so my wife and I and our daughter have been, extra precautious. But we don't know why some people have such a terrible cytokine storm and others really have a mild illness. But hopefully we'll tease that out. In the meantime, we'll continue to focus on identifying drugs that can work for the most sick patients, and oftentimes Castleman's drugs.
So coming back to your address that you gave us at ASCO, can I ask you, what are the key messages that you'd like us as oncologists, as well as fellow humans, people who have our own illnesses, families with illnesses? What are your key messages for us, David?
So I started my talk by sharing my different perspectives as a patient with Castleman disease. I actually also had a rare liver tumor called an inflammatory myofibroblastic tumor. So I've experienced oncology in a couple ways. But as a patient, as a caregiver of my mom with cancer, as a researcher, as a physician, and then also as an advocate, how these perspectives have been really critical to the progress that we've made. I talked earlier about crowdsourcing, and really at the heart of it, it's not about the fancy term like crowdsourcing. It's really just about bringing together multiple perspectives. And so I encouraged, and this is oncologists, but really anyone in the sciences or in medicine, to make sure that you're including all of those perspectives in the work that you do, whether it's on an individual patient basis, including all 5 of those perspectives for your patient in front of you, or it's across a disease. So you're really pulling them together, and even across multiple diseases. How can we Castleman's researchers work with related disease researchers like COVID-19 researchers? And so really encouraging this sort of cross multi-stakeholder effort. I think that's just been so critical to our success, and I can't encourage others enough about how badly that needs to be done. I shared a few messages from those perspectives. So the first was that hope can have many forms. There's the kind of hope that made me feel like maybe I could survive when I saw another Castleman's patient that was doing much better than I was, and maybe I could be like him. There's the kind of hope where you hope and you wait for that cure to come, which is the kind of hope I had with my mom. I just believed and hoped with everything that I had that she would survive. And then there's the kind of hope that we've talked about already, and that's the hope that inspires action, where you say, okay, I'm hoping for this thing. I'm going to do that thing because I'm hoping for it. And it doesn't have to be curing a disease. It could be that, you hope to spend more time with your grandkids. So maybe you're going to exercise a little bit more. Maybe you're going to take your diabetes medication. There are ways that you can turn hope into action that don't require experiments. I also shared about the power of humor and how during really tough times, finding things to laugh about are really important. And I don't want to generalize too much, but I have to say my Australian friends are so good at finding humor at the right time. It's like again, I don't want to be too generalistic, but wow, Australians that I have dealt with, it seems like you guys just have this knack for during really tough times, finding the right time to laugh about something. And it's not inappropriate laughter. It's like, how can you find some lightheartedness in the midst of a tough time? I think that's something that us Americans could do a better job of. I also shared about how there can be solutions that hide in plain sight, like the drug that I'm on, and how we shouldn't just think always about new drug development, but we should also think about the drugs in the rearview mirror. And I talked about how something we mentioned earlier, that it really does take an army, that if this was me on my own, we would have made no progress. But because I had this amazing army, and it should be chasing our cure, because it really has been an army working together to chase our cure. And so those were a few of the messages. And I think just one that I would end with that we touched on once before, and that's the idea around creating silver linings, that during a tough time, don't just look to say, okay, something positive came from this, but let's say, what can I do today during this really, really tough time to make this into something that's positive?
So, David, you're everything rolled into one, and it must be quite cheap to have a conference with you, because you can be the patient, the advocate, the researcher, the doctor, the businessman. I can't thank you enough for being so generous with your time and with your personal story. I think you're an inspiration, but your way of thinking and changing that paradigm is really something I think that may help accelerate us in research from the relatively modest progress we've made for all the money and time invested.
Well, thank you so much. It's been such a pleasure being on the show with you. And I so appreciate you helping to share our message of hope. And it's also so special that you're helping to share tangibly how we're trying to change the medical community. So thank you.
You've been listening to the Oncology Podcast. If you enjoyed today's edition and would like to subscribe, head over to our website, oncologynews.com.au, and sign up to our newsletter. Thanks for listening.